Let's take a look at the periodic table. Remember, the metals are found on the left and the centre of the table, and the non-metals are located on the right above the thick lined step. Now, elements are ordered by their atomic number, which means the number of protons in their atoms. The lightest element has a proton number or atomic number of 1, which is hydrogen. The second lightest element is helium, which has an atomic number of 2, and so on. And these elements are arranged a bit like words in a sentence in lines across the periodic table. And these lines that go across are called periods. Elements are also set out to be grouped according to their similar chemical properties, and these are simply called groups. These are vertical columns that go down the periodic table. So for example, group 1, lithium, sodium and potassium all have similar properties. And group 7, the halogens on the non-metals, they all have similar chemical properties as well. In each group, there's a gradual change in properties when we move from top to bottom of each group. When we look at group 1, their melting points and boiling points decrease as we go down the group. Note that groups can have names as well as numbers, so the group 1 elements can be named alkali metals, group 2 can be named alkaline earth metals, group 7 can be named halogens, and group 8 or 0 is the noble gases. The group number also tells you the number of electrons in the outer shell of each atom. So lithium, sodium and potassium all belong to group 1, which means they all have 1 electron in their outer electron shell. Now it's the number and positioning of these outer shell electrons that take part in reactions and determine the chemical properties of an element. So the group number tells us the number of electrons in the outer electron shell of an atom. So what do the periods tell us? Remember, the periods are the horizontal rows of the periodic table. The period tells you the number of electron shells in an atom. So you can use the information in the periodic table to work out the electronic structure of an atom without even knowing the number of electrons. Sodium is in period 3, so an atom must have 3 electron shells. Sodium is also in group 1, so that suggests the atom must have 1 electron in its outer electron shell. Because we know the maximum number of electrons each electron shell can hold, from this we can work out that there are 11 electrons in a sodium atom. And this is what the electronic structure of a sodium atom looks like.